want to draw a helix of 3 second revolutions upon a cone that is having a diameter of 60 millimeters, a height of 100 millimeters, and a pitch of 80 millimeters. So such a cone will look something like this. So the base diameter, we said, is 60. The height of the cone is 100, and the pitch is the axial advance when you go through the revolutions stated. In this case, our helix is not going to start from the base and end at the apex, but rather it will end at the point where the pitch small p is located. Very important. So the 1.5 revolutions is going to go through, is going to fit from the base till the position of the pitch. So we can now begin. With your compass in a radius of 30, you can draw the circle. We have the base in place, so we now can go ahead and draw the front view. Now we'll have to locate our point P. And we know that the point P is 20 millimeters from the apex. So this is where our point P will be located. So you'd see that if I measured from the apex to the point P, where P here is the pitch, that will be 20. So that's where you position your pitch. So would go and then divide our circle into 8 equal parts. If we divided the circle into 8 equal parts, we would also have to divide our front view into 8 equal parts as well. But because we are doing a revolution and a half, I'd rather divide the circle into 12 equal parts and the front view rather into 8 equal parts. Let's now label the divisions. So I have P. This is capital P for the point P, not pitch. And then I'm back to 8. So another half revolution. So 9, 10, 11, and 12. So that is my 1.5. So we'd have to divide the pitch distance into 12 equal parts as well. So let's go ahead and do that. Now, mind you, the pitch is 80 millimeters, so 80 divided by 12 will give us 6.67 per interval. So that's what we're going to do. And then we'll label the points, or we'll label the divisions on the front view. So I'll locate my point P on the front view. So point P is there, and then point P on the base is also located there. What I'll do next will be to draw my vertical lines from the base to the bottom part of the front view and then connect to the apex. So now we can locate our points on the front view, and we know that's the intersection of, let's say, the projection line. So from 1 all the way from the base, and then 1 on the front view. The intersection of those two will give us point 1 on the front view. And then from 2 to 2. So let's go ahead and put those in place. So points 1 and 1, that will give us the first point. And then 2 and 2, our second point. 3 and 3, and then 4 and 4. 5 and 5. 6 and 6. 7 and 7. 8 and 8. So mind you, if we were doing one full revolution, then this will be the total curve that we get. This will be our full revolution or one revolution. So the remainder is going to be the half revolution, that is from 9 till 12. So same method, so 9 and 9. And then 10 and 10. 11 and 11. And then finally 12 and 12. So we can connect with a spline, but before we connect, we can put labels on them. So you would have to use your French curves to connect. Of course, because I'm using the software, I'll use a different approach. And we'll do well to remember that the point 4 to point 8 is behind the cone. Therefore, this section of the helix is going to be represented with hidden lines. Okay, so seeing as we have our points P1 to P12 on the front view, we want to draw the helix on the base or on the plan as well by projecting downwards the points P1 all the way to P12. Okay, so we'll project point 1 downwards by just drawing a line from the point 1 all the way to the 1, 5 divisional line on the circle. So when we draw the point down from P1, it hits this point. It hits this divisional line here, and that is our point P1. So this is the point P1. So for P2, we know that P2 goes through here, but because P2 goes through the 2, 6 line, which is vertical, we'll have to use a slight different approach. So what we'll do is we'll project P2 to the generator, and then you project from the generator with a line. So from the generator, we draw a line until it touches the diameter, and this is where it touches the diameter. And then we use our compass. So standing at the center of the circle, we open to that point where the line hits the diameter, and then we draw an arc until it touches the 2 line, which is at this point, and this will rather be our point 2. All right, so point 3 is easy. So for point 3, we just project point 3 until it touches the 311 divisional line, like that. So that's point 3. And then for point 4, we'll do same. So we project 4 until it hits the 4 divisional line, which is this one right here. So 4. All right, so before I continue with the next set of points, I want to label the first 4 so that I don't confuse us all. So from 5, we are looking for the 1-5 divisional line, which is that point here. So that is 5. Now when we get back to 6, we'll see that 6 is going through the vertical line through the base. So we use a similar technique as we did for point 2. So with our line, we'll project from the point 6 to the generator, and then all the way downwards until we hit the diameter. And then with a compass, standing at the center. So with your compass, you stand at the center of the circle, open to this point where you've drawn a vertical line to, and you draw an arc, but this time round we are going up and not down. And this point here will be point 6. Now we go to 7. So for 7, we project from this until we hit the 7 divisional line, which is this point right here. And then from 7, we go to point 8, project from 8 all the way until we hit 8 divisional line. And that point is our point 8. Again, before we continue, let's label the next 4 set of points that we've gotten. Okay, so from points 1 to 8 on the plan would actually represent a full revolution. So we go ahead, and then from 9 to 12 will be the half of a revolution that we have to add. So same method, I'm changing the line to yellow just to differentiate. So from 8 we go to 9. So from 9 we drop this downwards, and this is our ninth line. So that is point 9. Now when we get to point 10, now mind you, 1 and 9 and 5 are on the same divisional line. So 2, 10 and 6 will be on the same, 3, 11 and 7, and then 4, 12 and 8, and actually P. Okay, so when we get to the 10th point, you see that we are facing that challenge where the point is going through the vertical. So we'll have to resort to the technique we used at 2 and 6. So line, this will rather go to the generator and then all the way downwards. So from this point, then we draw that. And that will be our point 10, and then 11. So from 11, so for 12, because it's not at the vertex, it won't be at the center. So we have to use same technique. So from 12 to the generator all the way downwards. Now I have a lot of lines there, so be careful not to confuse yourself. All the way to the divisional line. And then we would use our compass, stand at the center, open to where we got to, and this time we go up and not down, like that. And that will be point 12. You see that point 12 is not going through the vertex. So let's label the points. So now that we have all the 12 points projected onto the plan, we can now connect through with our French curves, beginning from P1, P2, P3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And that's about it. That will be our solution.